You step on a scale. You see a number. Maybe 70 kilograms. Maybe 150 pounds. That's your mass. Your weight. The stuff you're made of. But here's a question nobody asks. Where does that mass actually come from? You think it's from atoms? From protons and neutrons and electrons? From the particles that make up your body? Wrong. Almost completely wrong. 99% of your mass, everything you weigh, everything that makes you solid, doesn't come from particles at all. It comes from nothing. From empty space. From pure energy. From motion frozen into existence. And I'm about to show you that the mass you carry around every day is one of the most misunderstood concepts in all of physics. Now, if this sounds confusing, good. It should sound confusing. Because what I'm about to tell you contradicts everything you've been told about mass your entire life. Teachers tell you atoms are made of particles. Textbooks show you diagrams of little spheres. Protons and neutrons as tiny balls packed into a nucleus. Electrons orbiting around them like planets around a sun. It's a lie. A useful lie maybe, but a lie nonetheless. And when I first learned this, I didn't believe it either. I thought there had to be a mistake, that someone had calculated wrong. But the evidence is overwhelming. The mathematics is clear. The experiments confirm it. So let me show you exactly where your mass comes from. Let's break down what you're actually made of. Your body is mostly water, H2O. Each water molecule has atoms, hydrogen and oxygen. So you're made of protons, neutrons, and electrons. Now, what gives those particles their mass? Most people who've heard of modern physics will say, the Higgs boson, the Higgs field, that's where mass comes from. They saw the news in 2012. The Higgs was discovered. Headlines everywhere. The God particle found. The origin of mass. Scientists celebrated. Nobel Prizes were awarded. The world thought we'd finally answered the fundamental question. Where does mass come from? Great. So your mass comes from the Higgs field. Except no. The Higgs field gives particles their intrinsic mass. Their fundamental mass. And for electrons, that's significant. Electrons get all their mass from the Higgs. But electrons are tiny. An electron's mass is about 1/2000th the mass of a proton. You have trillions of electrons in your body. But all of them combined contribute less than 1% of your total mass. Your electrons? They weigh about as much as a single eyelash. Everything else? That's protons and neutrons. So where's the other 99%? In protons and neutrons, your body is overwhelmingly made of protons and neutrons. They're what gives you weight. And here's the kicker. Protons and neutrons barely get any mass from the Higgs field. Maybe 1%, maybe 2%. So where does the other 98% of their mass come from? If your brain is already spinning, drop a comment right now, because this is just the beginning. Protons and neutrons are made of quarks. A proton has 3 quarks, 2 up quarks and 1 down quark. Now, quarks do get their mass from the Higgs field. But here's the problem. If you add up the masses of the 3 quarks inside a proton, you get about 9 units of mass. But a proton itself weighs 938 units. Let me say that again. The quarks inside a proton add up to about 9. But a proton itself weighs 938. That's 100 times heavier than the sum of its parts. It's like weighing 3 marbles and getting 10 grams, then putting them in a box, and the box suddenly weighs 1 kilogram. Where did the extra 990 grams come from? The box didn't add weight. You didn't pour anything in. The marbles are the same. But somehow, the system weighs 100 times more than it should. That's a proton. So, where did the other 929 units come from? Where did 99% of the proton's mass come from, if not from the quarks themselves? The answer is going to sound insane. But I'm going to show you exactly how it works. Everyone knows Einstein's equation. E equals mc squared. Energy equals mass times the speed of light squared. Most people think this means you can convert mass into energy, like in a nuclear bomb. And that's true, but it's backwards. The real insight is that mass is energy, not can be converted to, is. Mass is just energy that's been frozen, concentrated, confined to a region of space. Think about energy for a second. Energy can exist in lots of forms. Kinetic energy, the energy of motion. Potential energy, the energy of position. Chemical energy, energy stored in bonds between atoms. All of these can transform into each other. A ball rolling down a hill converts potential energy to kinetic energy. Chemical energy in your muscles converts to kinetic energy when you move. Mass is also a form of energy. When you have mass, You have a certain amount of energy just sitting there, existing. Let's make this concrete. 1 kilogram of mass contains enough energy to power a small city for weeks. That's the energy released by the largest nuclear bombs ever tested. All from 1 kilogram of matter. Not because you're converting mass to energy, because the mass was energy all along. The only reason we don't notice this equivalence in everyday life is because c² is so enormous. A tiny amount of mass contains a staggering amount of energy. If you could unlock just the mass energy in a grain of sand, you could power your house for months. But we can't. The energy is locked up, confined by forces we can barely touch. Now, you might be wondering, okay, but why is mass energy? What's the actual mechanism? Most videos stop here. They just say Einstein proved it and move on. I'm not going to do that. Let me show you exactly how this works. When we ask where does mass come from, we're really asking where does this concentrated energy come from? And the answer is from other forms of energy. Specifically, from motion, from fields, from forces holding things together. Imagine you have two particles far apart. They're not interacting. No forces between them. Each one just floating in space, minding its own business. Now bring them close together. Let a force bind them together. When they bind together, they release energy. A photon shoots out. Heat radiates away. Something carries energy out of the system. The bound system now has less energy than the two separate particles did. And since mass is energy, the bound system has less mass than the sum of its parts. This is real. This is measurable. A helium nucleus weighs less than the separate protons and neutrons that formed it. The difference is called the mass defect. And that missing mass? It was released as energy when the nucleus formed. That's how the sun works. That's how fusion works. Hydrogen fuses into helium, and the helium weighs less than the hydrogen did. The missing mass becomes energy, light, heat, the radiation that keeps you alive. Every photon of sunlight that hits your skin is carrying energy that used to be mass. Mass that disappeared when hydrogen atoms fused together in the core of the sun. Without this process, without mass converting to energy, the sun would be dark. The earth would be frozen. You wouldn't exist. But here's the twist. Binding energy usually reduces mass. When you stick things together, they weigh less than before. So how does motion and energy inside a proton create mass? How does a proton weigh more than its parts instead of less? The answer lies in confinement. If this is blowing your mind, hit that like button, because we're going even deeper. A proton is made of 3 quarks. Those 3 quarks, by themselves, have very little mass, about 9 units total. But the proton weighs 938 units. That extra 929 units, 99% of the proton's mass, comes from the quarks moving, and from the force field, the gluon field, that holds them together. Quarks are held together by the strong nuclear force. The particles that carry this force are called gluons. Gluons are to quarks what photons are to electric charges. Photons carry the electromagnetic force. Gluons carry the strong force. But there's a critical difference. And here's what makes this force bizarre. The farther apart you try to pull 2 quarks, the stronger the force between them becomes. It's like a rubber band. Stretch it, and the force increases. Except with quarks, the force increases without limit. Pull harder, the force gets stronger. Pull even harder, stronger still. Eventually, you're putting so much energy into separating the quarks that the energy itself creates new quarks. A quark-antiquark pair pops into existence. Now you have 4 quarks instead of 2. You can never pull quarks apart. If you try, you just create new quarks from the energy you're putting in. This is called confinement. Quarks are permanently confined inside protons and neutrons. Nobody has ever seen a free quark. Nobody ever will. The force simply won't allow it. It's one of the most frustrating and beautiful properties of nature. The harder you try to look inside a proton, the more the proton resists. The act of looking changes what you're looking at. Now you might be thinking, okay, but what does that have to do with mass? Everything. Because confinement traps energy, and trapped energy has mass. So, what's actually happening inside a proton? 3 quarks zipping around at nearly the speed of light, constantly exchanging gluons. Those gluons create more gluons. At any instant, there are dozens, maybe hundreds of virtual gluons flickering in and out of existence inside the proton. And here's the really strange part. Gluons themselves carry the strong force, so they interact with each other. They stick to themselves. Photons don't do this. Light doesn't interact with light. Shine 2 laser beams at each other, and they pass right through. But gluons? Gluons interact with gluons. The force carriers themselves feel the force. This creates a feedback loop. Gluons create more gluons. Those gluons create even more gluons. The field becomes incredibly dense and chaotic. The inside of a proton is a seething, chaotic sea of quarks and gluons, all moving at nearly light speed, all interacting constantly. That chaos has energy. The quarks are moving. Kinetic energy. The gluons are there. Field energy. Virtual particles are popping in and out. Vacuum energy. All of that energy is confined inside the proton, trapped by the strong force. And since energy is mass, all that confined energy shows up as mass. That's where 99% of the proton's mass comes from. Not from the Higgs field. Not from the intrinsic mass of the quarks. From the motion and fields inside the proton. From the energy of confinement itself. Think of it this way. You have a tiny box, about a femtometer across. That's a millionth of a billionth of a meter. Inside that box, particles are moving at 99.9% the speed of light. Fields are fluctuating wildly. Energy is sloshing around like water in a shaken bottle. You can't open the box. The strong force won't let you. All that energy is trapped, and trapped energy has mass. The box weighs more because of all the motion and chaos inside. That's a proton. This isn't speculation. We've measured this. Computer simulations of quarks and gluons inside protons predict the proton mass to within 1% accuracy. These are computational models that predict proton mass perfectly. Starting with just the quark masses and the strength of the strong force, we can calculate that 99% of the proton's mass comes from gluon fields and quark kinetic energy. The numbers match experiment perfectly. We didn't assume this. We calculated it from first principles, and nature confirmed it. So when you step on that scale, 99% of the number you see is coming from motion, from quarks zipping around inside protons and neutrons, from gluon fields churning, from energy confined to tiny regions of space. Now you might be thinking, wait, if I'm just energy, why do I feel solid? Why can't I just pass through a wall? Great question. The answer is that different patterns of energy interact in specific ways. The electromagnetic field patterns in your hand repel the electromagnetic field patterns in the wall. Not because there are little particles bouncing off each other, because the fields push against each other. Solidity is a consequence of how energy patterns interact. When you touch a table, you're not really touching it. The electron clouds in your hand and the electron clouds in the table repel each other electromagnetically. They never actually make contact. You feel resistance from fields pushing against fields. Everything you've ever touched, you've never actually touched. You felt electromagnetic repulsion, field against field, energy against energy. So your mass comes from energy. Energy confined inside protons by the strong force. Energy organized into atoms, energy in fields. But this leads to a profound question. If mass is just energy, and energy can't be created or destroyed, where did all this energy come from in the first place? And why can't we just create more mass whenever we want? If you're still with me, leave a comment telling me which part shocked you the most. Because we're about to answer the biggest question. If mass is just energy, why can't we create mass out of thin air? Why can't we just grab some energy and make matter appear? The answer is, we can. But there's a catch. Take a high-energy photon, a gamma ray. Bring it near an atomic nucleus. The photon disappears. In its place, an electron and a positron, matter and antimatter. The photon's energy became mass, E equals mc squared in reverse. This is called pair production. It happens constantly in particle accelerators and in space. Cosmic rays hit the upper atmosphere. Gamma rays from distant supernovas arrive at Earth. They slam into atoms and create matter-antimatter pairs. So yes, you can create mass from pure energy, but here's the catch. You need a lot of energy. To create just 1 gram of matter from pure energy, you'd need the energy output of a large power plant running for a month, just to make 1 gram. A paperclip's worth of matter requires the energy equivalent of a nuclear bomb. Creating mass is easy in principle. Just concentrate enough energy in one place. But it's hard in practice because c squared is huge. The speed of light is 300 million meters per second. Squared? That's 9 times 10 to the 16th. 90 quadrillion. So to create mass, you need to concentrate an enormous amount of energy into a tiny space. That's why we don't see matter popping into existence around us. The energy density required is extreme. And there's another constraint: conservation laws. Energy is conserved. You can't create it from nothing. Charge is conserved. If you create an electron with negative charge, you must also create a positron with positive charge. Lepton number is conserved. Baryon number is conserved. Quantum numbers must balance. These laws limit what you can create. You can't just make a proton appear. You'd have to make a proton and an antiproton, and then they'd probably annihilate back into energy anyway. Nature is balanced. For every particle of matter you create, you must create an equal particle of antimatter. And when they meet, they destroy each other. This is why stars work the way they do. Stars don't create mass. They convert one form of mass into another. Hydrogen fuses into helium. The helium weighs less than the hydrogen. The missing mass becomes energy. Stars are mass-to-energy converters, not mass creators. So mass is energy. Energy confined by forces. Energy organized into patterns. But what does this mean for the universe as a whole? Let's step back and look at what we've learned. Your mass, almost all of it, comes from the motion and fields inside protons and neutrons, quarks moving at nearly light speed, gluons binding them together, virtual particles flickering in and out. All that chaos, confined by the strong force, shows up as mass. This explains so much. Why different atoms have different masses? Because they have different numbers of protons and neutrons. Why isotopes of the same element have different weights? Same protons, different neutrons. More neutrons means more mass. Why fusion releases energy? Because when nuclei combine, some of the binding energy is released. The product weighs less than the reactants. Nuclear weapons work because of E equals mc squared. Not by converting mass to energy in some mysterious way, but by rearranging protons and neutrons into configurations with lower binding energy. The missing mass, typically about 0.1% of the total, becomes explosive energy. In the sun, hydrogen fuses into helium. 4 hydrogen nuclei become 1 helium nucleus plus 2 positrons and 2 neutrinos. The helium weighs slightly less than the hydrogen that formed it. That tiny fraction of mass, converted to energy, powers the sun for billions of years. 4 million tons of matter are converted to energy in the sun every second, and it's been doing this for 4.6 billion years, and it will continue for another 5 billion years. In particle accelerators, we do the reverse. We take energy from electricity, from magnetic fields, and concentrate it into tiny regions. When protons collide at high speed, their kinetic energy can create new particles, Higgs bosons, heavy quarks, W and Z bosons, particles that didn't exist before the collision. Where did they come from? From the energy of motion. Kinetic energy became mass. The Large Hadron Collider smashes protons together at 99.9999%, the speed of light. The kinetic energy is so enormous that it creates particles hundreds of times heavier than the protons themselves. So when you step on that scale and see that number, you're not measuring stuff. You're measuring energy. Energy that's been confined by forces. Energy that's been organized into stable patterns. Energy that resists acceleration when you try to move it. That resistance, that inertia, is what we call mass. Remember when I said 99% of your mass comes from nothing? That wasn't quite accurate. It comes from something. It comes from energy. But that energy isn't sitting in little particles like marbles in a bag. It's dynamic. It's active. It's constantly moving and changing. Inside every proton in your body, quarks are zipping around at 99.9% the speed of light. Right now. This instant. Gluons are being exchanged billions of times per second. Virtual quarks are popping in and out of existence. All of that motion, all of that chaos, all of that energy, that's you. That's your mass. You're not a collection of static particles. You're a symphony of motion, frozen into patterns that persist. If you're sitting there thinking this can't be right, I understand. This idea violated every intuition I had when I first learned it. But here's the thing. It's not just theory. We've measured this. We've tested this. Every nuclear reactor proves this is real. Every star in the sky proves this is real. Every particle accelerator proves this is real. The numbers match. The predictions work. The experiments confirm it. Mass is energy. Energy is motion. Motion is confined by forces. That's the reality. And once you see it, the universe becomes more beautiful. You're not made of dead, inert matter. You're made of energy. Pure energy. Organized into patterns stable enough to think and feel and wonder. Every atom in your body is a tiny storm of activity. Particles moving at nearly light speed. Fields churning. Energy dancing in patterns that have persisted for billions of years. The atoms in your body were forged in stars that exploded billions of years ago. The energy patterns that make you who you are have been propagating through the universe since the beginning of time. So step on that scale one more time. Look at that number. Now you know what it really means. It's not measuring how much stuff you have. It's measuring how much energy is confined inside you. Energy from the motion of quarks. Energy from gluon fields. Energy from the fundamental forces holding matter together. 99% of your mass is motion. 99% of your mass is energy. 99% of your mass comes from the chaos inside protons. And that is far more amazing than any simple answer could ever be. You are not matter that happened to gain some energy. You are energy that happened to take a form stable enough to contemplate itself. And that, I think, is wonderful. If this changed how you see yourself forever, make sure you subscribe. Because next week, we're diving into quantum field theory. If you're made of energy patterns in fields, what are particles really? The answer will destroy everything you thought you knew. And leave a comment. What percentage of your mass did you think came from the Higgs field? I read every single one. Thanks for watching. And remember, you're not solid matter. You're frozen motion. You're energy that learned to think.